Hello and welcome to today's class. Let's proceed with the concept of ionization energy. First things first, let's define, um, I'll call this concept, I'll call it IE. So if I say IE, I mean ionization energy. So in my discussion in this video, you might be hearing IE. For the fact that you're getting IE, I mean ionization energy, right? So first things first, if I define IE for you, your very first task here is that you need to know some certain things, such as note please. I'll give you two things to note before we move on to definition of ionization energy. All right, note please. Note number one, please. Note this very important. Note number one, please. Note. Electrons in an atom are held together. Electrons in an atom are held to the nucleus by electrostatic force of attraction between the nucleus and the electron. All right, let me explain what I've just said now. I said that electrons, these electrons here, I are seeing, these are called electrons. Why this one here is called the nucleus, right? So we're saying that this electron here of an atom are held to the nucleus. They are held to this nucleus by electrostatic force of what there of attraction, right? Because electron are negatively charged while nucleus are positively charged because it contains proton and proton are positively charged ion. So because of the positivity of the proton and negativity of the electron, it creates an attraction between the two concepts there. Because in physics, there's something called like charges repel while unlike attract. So this here, this proton is positively charged and the electron is negatively charged, they will attract because they are opposite charges. That's by the way. And but it's also important to note that in an atom like this, there are two forces in action. In an atom, as this one here, there are two forces in action. The first one is called the nuclear force. So the second one is called the screening effect, right? So what's a nuclear force? What is screening effect? Definition. A nuclear force is a force coming from the nucleus in brackets, proton in particular, and they are dragging electron to themselves. That's how you define a nuclear force. So a nuclear force is also known as the nucleus, which is also what the protons, right? These protons. So they drag electrons to themselves. So this nucleus, their goal is to drag all these electrons to themselves. That's your first force that acts when it comes to atom. The second force is called the screening effect, or you call it the shielding effect, right? It's called screening effect or shielding effect. So what is a screen effect? This happens or this occur when the outer electron and inner electron are repulsion. When the outer electron and inner electron repel, right? It means it's also called electrostatic force of repulsion. So the second force that exists when it comes to atom, that acts in atom is called screen effect, and it could be observed by the outer electron or the inner electron. Observe that this outer electron and inner electron, they are not, they can never magnet together, they can never stick together because um it is negative charges, so they cannot attract themselves, right? So in a case where you have two electrons this way and they cannot attract, it's called the screening effect, right? The distance between the outer electron and inner electron, right? It's also called the electrostatic force of repulsion. Electrostatic force of repulsion. They will repel, right? They will rebel from each other because they cannot attract each other. These are like the two forces that act on an atom: the nuclear force and also the screening effect, or you call it the shielding effect. That is note number one for you. Note number two. That's note number one. Note number one. Done. Note number two. Note number two. Note number two says When an atom absorbs sufficient energy, an electron can be completely removed. Come again. When an atom absorbs sufficient energy, an electron can be completely removed. So what do I mean? So it is now from this thing I just gave you, for number two I gave you, it is possible to channel energy into an atom. So if I have an atom this way, it is possible for me to bring in an energy, right? Sufficient energy into this atom. And if the energy I applied or I integrate into this atom, if the energy is too powerful, too sufficient enough, of course, it can kick off an electron away. It can remove an electron away from this atom. So I'm saying that when an atom absorbs sufficient energy, an electron can be completely removed. So it is one thing to know as we study in the concept of ionization energy. So it is possible to channel an energy into an atom, thereby making an electron to be completely removed, right? So bear in mind that as you are going in the study of this concept, that when energy is too powerful, too sufficient enough, that is applied to an atom, it can remove an electron, right? So that's like the second thing to know when it comes to ionization energy. All right, now at this junction here, let's define um, ionization energy. So what is what is ionization energy? All right, what is IE? All right, definition please. Ionization energy is the amount of energy required to remove the outermost electron from a neutral atom or a ion in its gaseous state, forming a positive charge ion. I said radiation energy, right, is the amount of energy required. So the amount, the sufficient energy required, right, to remove an electron from the outermost shell. When I was removing this electron, I didn't remove from here or here. It's the last shell. The last shell is called the outermost shell. So your ability to remove an electron from the outermost shell of an atom, and that atom should always be in a gaseous state. I've given you, right, from a neutral atom or a ion. So the atom can be either neutral atom or that atom can be bearing a charge, right? For instance, you can be having sodium and sodium Na plus. So that Na plus sodium ion or sodium is a neutral atom. So it could be in sodium or sodium plus, right? So it could be a neutral atom or atom being a charge, right? In its gaseous state. So those atoms must be in a gaseous state and they're forming a positive charge. So at the end of everything, you should have a positive charge ion. What do I mean? All right, let's explain this properly. I said IE, right? IE is the amount of energy required. Listen, the amount of energy required to remove an electron from a neutral atom or an ion in its gaseous state. Those ions or those atoms must be in a gaseous state. So let's say for instance I have an atom, a neutral atom, let me call it X. This X now is in the gaseous state. Makes sense, right? So we said IE is the amount of energy required to remove an electron from a neutral atom. Here is the neutral atom. So I want to remove an electron from this. So I want to remove an electron from this. So let's say I remove an electron E minus. I just remove an electron from this, right? This is a neutral atom. and I remove one electron from this neutral atom, right, in a gaseous state. Moving on, please. In a gaseous state, right, it now says that um, forming a positive charge ion, right? So it must form what there a positive charge. So it means that at the end of the day, I'm having X, this X gaseous state, I'll have positive ion here. So I just have to add plus here. So it's more like saying I'm having a neutral charge here. This neutral atom, right? An electron is being removed, right? Such that left with what a positive charge ion. That's like the definition I gave you. So this is like the expression to the definition for ionization energy, right? So the amount of energy required to remove an electron. This is an electron. I remove an electron from this neutral atom, right, in the gaseous state. See, of course, in a gaseous state, thereby leaving it to form a positive charge ion at the end. So you can see this is your mathematical expression for ionization energy, as you can see on the board. All right, I haven't said this. I haven't said this. First things first. Let's move on, please. When it comes to ionization energy, right? We said the amount of energy required to remove an electron from a atom, from a neutral atom or an ion in a gaseous state, thereby forming a positive charge ion at the end. I said initially. Now, it's important to note that moving on, it's important to note that IE, right? It helps you measure how strongly atom holds on to electron. So I can also define IE as a measure of how strongly an atom hold onto its electron. So I can also define answer energy as the amount of energy required or a measure on how strongly an atom holds onto its electron, right? So you can compare a hen and its chicks, right? So when a hen lays egg, and the egg hatches, it gets connected. The mother hen gets connected to, the chick, every time it's with them. So it means that the IE is higher, right? So the amount of energy required to separate the chick and from the hen will be really, really sufficient enough because the mother hen holds onto the chick much more tighter. So it means if you are coming to separate them, it means you're going for a war. You understand? So you need to strategize and look, okay, how can I remove this hen from the chick? So you could probably give the other hen some rice and then get her distracted. You can carry one of the what I'm saying in essence is that it is not easy to carry the chick from the mother hen, right? It is not easy to carry a chick from the mother end like that. So you need to apply strategy and sufficient energy, right? That's like the concept behind this idea. Next class, please. Okay, let's move on. So I said the measure of how strongly an atom holds onto its electron, it's also called IE, right? So I can call IE the amount, or I can use it to measure how strongly an atom holds onto its electron. So when I was explaining the idea of so at this junction, let's look at it, the concept of first, second, and third IE, right? So this is what we call first IE, second IE, and third IE. They have their own laws. We look at them one after the other. So look at the first concept called the first IE, first IE. All right. So we have the first IE, second IE, and third IE. By definition, the first IE is the energy required to remove the first electron from a neutral atom. Your ability to remove the first electron, the first outermost electron from a neutral atom is said to be first IE. So let's say I'm having aluminium, for instance. So let's consider aluminium as the element here. So if I have aluminium Al, we said for Al it should be in gaseous state because IE talks about gaseous state. So if I have this what's it called, aluminium here, if I remove an electron from it, right, we said it should be left what? Al gaseous plus. So I just remove just one electron from a neutral atom, thereby leaving it as a positive charge ion. This is what we refer to as first ionization energy, also called first IE. This is how you define, and this is like illustration to your first RE. At this junction, let's look at the trends. Trends. By trends, I've explained what we mean by trend in the last two classes, right? So let's look at the trends for first IE. All right. Trends for first IE. It decreases down a group, in brackets, atoms get larger and valence electrons are farther from the nucleus, bracket close, and increases across a period, in bracket, greater nuclear charge greater nuclear charge attracts electron more strongly. Alright, in essence, I'm saying that for the trend for first IE is that it decreases down the group and increases across the period. That's all. So the important thing or the key take here is that when it comes to your first IE, it decreases down the group and increases across the period. Alright, you have that for yourself. Let's look at the second IE, please. Second, second IE. All right. Second IE. It says it is the energy required to remove a second electron from a singly charged ion. So the ability to remove an electron from a singly charged ion, in brackets X plus, in brackets X plus. All right. The ion here, we have, when it comes to ion, it could be either positive or negative, but in this case, it is positive, right? So your ability to remove an electron from a positive charge ion is called second ionization energy, or I call it second IA, as the case may be. All right. So I'm saying is that if I have all right. So I'm saying is that if I have let's say consider aluminium as in this case, so it means that my aluminium should be in a positive charge first, right? So it means I'll have Al plus in gaseous state, right? So this undergo um and this undergo IA such that I remove one electron from this Al plus, thereby leaving me with a positive charge. Now listen, here's the tax. When it was neutral here, I remove an electron, it gave me Al plus. Now it is now plus that is here now. I remove an electron, it will give me Al2 plus, right? Of course, in a gaseous state. So here's the tax. The more the value here, right? So the more the value here, the higher the product size look like. So if you observe this place here, here was neutral atom, here was positive charge. So a neutral atom having no charge means it will have just one charge here. But this one here has an existing charge here already, positive charge. So in other words, this product size will increase by the charge here. That makes it 2, right? And the fact that I'm having 2 here, it's a sign that this reaction is under what the second IE. The fact that I'm having just one charge here, it means it's under what the first IE, because in some exams they can give you several reactions and ask you which one is first IE, which one is third IE. You can spot them out by looking at this the product side of the reaction, the product side of the chemical equations, right? So this is how you spot out your second IE, right? So moving on, the trends for this please, the trends for second IE, all right? The trends for second IE always greater than the first IE because the remaining electron are held more tightly the positive by the positive charge ion. That's all. But the trend for second IE, there's nothing like it increases down the group or that concept. No. The fact is this, we said always greater than the first IE because the remaining electron are held more tightly by the positive charge ion. That is to say that second, hold on, what's happening? So second IE, right? Second IE is of course greater than what the first IE. IE. So what I'm saying is that the rule or the main trend for IE is that it decreases down the group and increase across the period, right? That's like the main trend unpredictable. But for all these other ones, second IE and third IE, it is more of like greater than and less than concept, right? Let's do the third IE, please. The third IE, yeah, and the trends for that too. So third or third IE, ionization energy. So this one says that the third IE is the energy required to remove a third electron from a doubly charged ion. From what there? A doubly charged ion. That is the ion is at 2 plus, right? In this case here, the ion here for second IE, the ion is at just 1 plus. Here was neutral. Then 1 plus down because what there a doubly charged ion, right? So it means that I'll be having something of this nature that Al2 plus, so Al gaseous form 2 plus because it should be doubly charged ion. So if this undergo an energy, it means that if I remove an electron from it, I'll thereby be left with what? I'll be left with what? Al in a gaseous state 3 plus. So this is 3 plus third, 2 plus second, and then plus that's first. You can use this to spot out what's it called? The state of the IE to which an equation should be, right? So that's how it works. The trends for this place, the trends for this, the trends for this trends trends for third IE. All right, the trends for third IE, it says it is higher than the second IE because the positive charge increases, making it increasingly difficult to remove additional electron, as I explained earlier, right? So it is more difficult to remove electron from this you know the Al3 plus, right? So that is how the concept works. So I'm saying in essence that the third IE, right, is greater than what the second IE. All right. So I said for the third IE, it means that the third IE is more greater than the second IE, which make more sense. So in the next video, we'll continue with the factors affecting IE. Right, there are three numbers which involve the atomic size, nuclear charges, and also atomic configurations. So look at this in our next video. So do well to watch this video properly. Right, if you have any misunderstanding, try to reverse back to watch properly before you leave any comments in the comment section. And also, I have a WhatsApp community where you can join. Check the video description. You see my link to WhatsApp community. You can join there and have access to my early videos uploaded before being uploaded on YouTube. You can have access to it in the group. And also do well to reach out to me if you have any questions or any confusion. See you guys in the next class and welcome to Excellent Link Academy. Bye.